bulb maybe lower bulb or get some credit minus bulb, okay, but see the here, okay, minus or $5 or but what the cost? This one, battery charger, battery, okay, maintenance of this one, okay, any company to do maintenance, just to attend to the home, you to pay 100 or 200 without anything, without do anything, okay, just to move from the company to home. After that, oh, this piece is not good, could be replaced. This piece, this wire is not good, I'm charging you 1,000 or more each time. The battery is also the battery is, oh, the battery is 10,000 or the battery is, and now, advantage of the grid type solar, but it kindly with such system you don't need to without battery. For this case, no battery, but sometimes you need to connect the battery. Without battery means without battery, so we use this one only on the day, and not at night. It will be off. Already the grid will be supplied. Okay, so, but is because the cost of the battery and the problems in the battery and battery charger, you can skip the installation of the battery or battery charger. Okay, so this one, high efficiency, 95%. Not the efficiency of the solar cell saying, no, this is efficiency of the system. Okay, according to financial economy, this one, from the start, down, up. You can check it later, this one, okay. High efficiency, but high efficiency not still this point is the efficiency of the solar cell is around 27, 26, okay, maximum. But this is efficiency of the system, okay. Of the system includes the distribution. See here, transmission and distribution system, okay. Of the system, not the efficiency of the okay. Now, no storage problem because we didn't install any storage system, any battery or any storage or charger equipment. So no storage, extra income sources. Okay, source or you can renewable connect more sources, okay, from the input from the grid or input from the solar cell, not input is fine, or from the diesel, from the small generator. So, in this, equipment for grid type solar cell. We saw the system. We got inverter, solar cell, meter, okay? So the equipment, power meter, grid type inverter, or micro inverter. Now the sizes for the level more and maybe stored at the back of the solar cell. Micro inverter. Okay. The grid type inverter, you can visit this. Type of some inverters used, okay, three-phase inverter and the input DC, okay, so price. So there are different ones for the batteries. Now, off the grid, solar, off the grid. First time on the grid, connected to the grid. Now off the grid. See? Off the grid. Solar panel. Connected to the charge controller. Charger. Okay, charge controller to this. Because we have charge controller, so we have charger. Charge the batteries. One or multi-battery, depending on the rating. So we add charger or charge controller, and we add 1, 2, 3, or 2, and battery. It's cost, but this is because this off a grid solar. See? Inverter. The battery charged from two sources, either from the DC panel, DC output panel, first time charge this one, or charges from the inverter, output of the inverter, output of the inverter, AC. So the AC connected to the generator or to the grid. This is optional generator. So input of the inverter. In this case, because this direction, so inverter will act as rectifier, convert the AC to DC to charge these batteries. And when we need power, the load needs power, the direction goes from battery to the inverter, DC to AC, this AC. Okay, this AC. So this is off the grid, not connected to the grid. This generator is optional generator, small generator, or DC generator, not a grid, because this is off a grid. Sometimes install only solar cell to the home. No need to connect it to the grid. Okay, but when connected just without a grid, we need battery, bike, and charger. Why?
because on day is already no need to the battery. Solar panel direct goes to the load, inverter and load. But at night, no. Battery will discharge inverter the power to the home. And this is optional. Maybe limited or no, we can't do that this. Okay, to minimize the cost. But the higher cost from this one, higher cost from battery and battery charger and maintenance, installation and maintenance. The problem is the maintenance, not the installation. Now, any question about this one? This is off grid, no grid, no national grid connected to the network. To this network. Same on the above figure. See here, battery. This is solar cell charge control to charge fog batteries, and this connect. This is without generator. Same. This one or this one, we can't. This one. Option. But this, the home not connected to the grid, to the AC grid, to the main grid. Just supplies from solar cell. Okay? But the reliability for this kind is high. Why? Because you know, maybe no sun, maybe no, maybe any fault in these panels, or any faults in the batteries, or any wrong connection, or I don't know. This type is remote location. Okay, sure. Location is full self-efficiency. Sufficiency, sorry. Sufficiency. Okay. Equipment for this type is battery, charger, panel, sugar, DC panel, that's it. Okay, and meter, inverter connected to this one. So, see, since off-grid system is not connected to the electricity grid or to the national grid or to the infinite supply. It must be designed to generate enough power through the year or through the day, not the through the day. This is for winter. For summer is okay, and depend on the state. Maybe the state in the north, but in Houston is okay. Texas, this is working. No, state, no. There's no sun. Light is not enough to generate power during the day and charge the battery tonight. It's not enough. Now, so typical parts: solar charge controller, battery, buying DC connect switch. This you can ignore this one. It's, changeover. It's called changeover. Okay, but DC. inverter, backup generator, this is the option. Okay. And you can visit this website to read more information. Now, hybrid solar system. This is perfect. This is okay. This is okay. See? Hybrid. Sometimes on grid, sometimes off grid. Depend. See here. First step, solar panel supply DC power to the inverter. And inverter charge the battery. Battery, one battery or multi batteries, depend. Okay? Supply. And part of this power converted to AC to goes to the home or to the load. And again, if the load needs more power, can take from the grid in this direction, from the grid to the if the power generated from the inverter more than demand power, the power, extra power will go to the grid. Same concept of on grid. Okay, but if the grid off, this will be on. If this off, this will be on. Okay. Okay. Maybe it's more expensive, but it's more relevant. More relevant. So this one is best one. Yes. Off. Grid. Tie and off. Tie on grid or off grid. This combination between both of them. Here, this figure. And also again, solar cell supply DC power to the inverter, and the inverter convert the DC power to the AC to the load. And grid supply inverter, but in this case it will be work as rectifier, not inverter, because the output of the city network is AC. AC converted by AC to DC and DC to AC to get power, or you can connect with this one direct. Back to the from the grid to the load. The components, what do you need the space? Yeah, sure. I will. Now, advantage of this one, reasonable price of such flexibility. Hybrid solar is are least expensive than off-grid. Sure. Sure. See, this one is hybrid solar systems are least expensive than off-grid. Why? Because off-grid we need the battery all the time, off the grid, no, all the time. But in this case, no. Sometimes need the battery supply or sometimes connect to the grid. Okay. And total energy control with a hybrid system. Homeowners can take advantage of change in electricity rate through the day. For example, you can program your home and vehicle to consume power during off-peak hour. Peak hour is during from 11 a.m. to 6 p.m. It's peak power. Evening or before afternoon by hour to before evening. Okay, this is peak. Peak hour means power with time. Is peak power between around 11 a.m. to 6 p.m. To 6 p.m. It's peak power. The system need power during this time. Equipment for this one is charge controller, battery bank, DC disconnect switch. This is additional, you can optional, you can remove it. Okay. Battery basic grid tie inverter also, and power meter. Sure, power meter is required for all of them because it measure the DC or AC power to count the money. Okay, money or benefit from this system to get from the company. Already smart meter. This is power meter or smart meter. Okay, smart meter is part of the smart grid. Okay. I think it's more from this one. I will upload this one, and after that, this sizing of the solar cell. This is not today. When we finish the power electronics devices require the design, we will discuss this part, size of solar array. Okay. Now, what time is it?
5:55.
5, 6 o'clock. So no need this. I think is this one to right. Design solar cell system. This solar cell. The input light and temperature. light and light and temperature. Output DC voltage, DC current, DC power, where power equal V DC I DC. This is VDC. The solar cell. Now, this is solar cell. Now, I don't know our load DC or AC. I don't know if we need to step up, step down voltage, or step up, step down current. Okay, so I don't know if we need to convert the DC output from the panel to the AC, or convert DC output from the panel to the DC with different voltage level. DC to DC, we'll use DC to DC converter. Step down or step up, we need more voltage, push the voltage, or step down back voltage. I don't know. I don't know also if we need more current or less current. Okay, so we can design all these parameters according to the load requirement. Check the load. The load, your load is DC or AC. Okay, so now, now for DC load, for DC load, light, temperature, positive, negative, if the load DC load as DC motor, okay, DC motor, or DC, any DC load. Okay, so here, DC load, DC motor, DC load, DC motor, DC charger, resistive load. The resistive load also is resistive load also is DC, but inductive load is not DC. Capacitive not, because the capacitive load will be open. The inductive load will be short circuit at DC. Now, this load, maybe we need to rise the voltage generated from the solar cell. We need to rise. So, we need to connect DC to DC converter, DC to DC converter, or DC chopper, DC chopper. And still this positive, negative. Also again, DC chopper, maybe step up, maybe step down. So for DC to DC converter, we have another step down, mean down. Step down. Step down for buck converter, or step up. Boost converter. There are 14 or 15 types of the converter, but no need to choose any converter, just either step down or step up. We need to rise the voltage or down the voltage, or we need to down the current or rise the current, depend. We will discuss this converter with the power electronics section. This class. Any question, please? Now, for AC for the AC, for AC load, any AC load, for the AC load, any AC load, motor or light AC, AC, but we don't know if the AC is three-phase or single-phase. So now, solar cell, light, temperature, and positive, negative, AC load, AC load, three-phase, single-phase, same. So here AC, AC. Which device need to convert the DC to AC? Inverter. Inverter will convert the DC power to the AC. Here. DC to AC converter, or inverter, or inverter. Or inverter, and here is AC. And AC load, maybe single phase, or maybe three-phase load. This 2 phase or four phase. All these special cases, not general, but we're talking about the single phase and three phase. Look, practical. Commonly, there are either single phase or three phase. Single phase as induction motor, single phase induction capacitor motor, okay, shaded pole motor. Three phase, large three phase induction motor, or large three phase synchronous motor, or large load. And DC to AC, inverter or converter. Converter is either single phase, bridge, or three phase bridge. Either single phase bridge or three phase bridge. Okay? And single phase bridge, inverter, either square or semi-square or pulse square, three phase inverter, 120 conduction angle or 180 conduction angle system, depending on the firing angle for the thyristor or transistor. Any question? No? Okay, so now we need to study the power electronic devices. We need to study the DC to AC converter and DC to DC converter, okay? And after that, we need to study for the wind turbine, we need to study the inverter, rectifier, and details, okay? Now, we need just to study the DC to DC converter and DC to AC converter. But before that, I will give you a review about the devices, power electronic devices. It's actually it's not devices, it's element of device, but some references called this power electronic devices. First one is power diode. Power diode. Not electronic diode, different. This is power diode. Okay, same simple anode, cathode, K or C, same, okay? And this is IA. So the relation between IA and VAC from anode to cathode given as proportional with the exponential function in the forward. And in the reverse bias, this is reverse Zener. Zener voltage. Now, what is meant by forward and bias? And this is Zener effect. Zener effect. That is mean forward and reverse bias, and it is mean by Zener effect. Forward bias. P N. This is the physical or crystal concentration of the diode. Positive, positive, negative. It's positive, negative. Forward bias means the bias voltage V, the positive terminal of the DC source connected to the positive, and negative terminal of the source connected to the negative. Okay? Positive, positive, negative, negative. It's forward. And the current will follow on the positive terminal, follow the PN junction. This is junction. This is the junction. This is small junction. This junction between P and N.
Isn't the depletion region this one?
Yeah, this is the depletion region, small, narrow.
Yeah, very small.
Yes, narrow, because this is forward. Okay. For reverse bias, same. P and this is diode, positive, negative. The negative terminal of the DC connected to the positive, and the positive terminal of the DC supply connected to the N. Now, N, P connected to the negative, N connected to positive. So the depletion region will be large. Large means the current follow, current should be I is very small, it's called IS, saturation current. Saturation current. The depletion region is very wide, okay, very wide. But if we increase the supply voltage, this material will be breakdown. Breakdown means all the material will be depletion region. Okay, breakdown. Breakdown means the current will follow high current and the voltage is fixed at one value equal to Zener diode. Breakdown is breakdown. Breakdown. The breakdown and the reverse. all the material converted to depression region. And the current IS follow, okay. Follow, this is Zener. Zener effect. Zener effect. Zener. Any question, please?
So if you break down, was on values,
So,
values, you break down. What are-
at breakdown, high current follows, but reverse current, where this one, see here? Reverse current follow, high current, but reverse, okay? And the voltage would be constant at VC, is okay? Any question, please?
I have a quick question.
Yes.
So why did we scribble in between like P and N for the reverse bias?
Why is in this case, see here, why the depression region wide?
Yeah.
Very good. Okay. See, for forward. For forward. P and. Or let me write here to okay, this see, this positive, right? And this negative. This all this side is positive. P positive.
Yeah.
False.
Yeah.
Okay, false, positive, 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 positive. So this positive will push the positive charge to the other side.
Okay.
And here electron, negative, 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 negative. Okay. Also, this P push the holes to the other, okay, and to rotate them.
Yeah.
And this negative push the electron to this side. So this side, so the depression region will be narrow.
Okay.
While in this type, no, negative with positive, this holds. Positive, positive, will,
Okay.
this holds to this side, and this electron to this side. Okay, so the depression region will be wide, but my question, what the sign on this one? Is okay, negative, 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 negative here.
Like positive, negative would be no sign.
No sign,
No,
yeah.
yeah.
Yeah, it's
Balance.
no balance, yeah. Okay, so here is so this will go on this side, so the depression region will be
Neutral.
wide.
Okay.
And at this case, we change it V, increase V, so increase the reverse bias. Okay, so the material breakdown and reach to the voltage constant breakdown is open circuit. Okay, open circuit equal to this V.
Okay.
Or equal to VZ, VZ.
Okay.
Okay? Because the material is breakdown
Okay.
due to the reverse bias voltage.
Okay.
Okay? Any question? This power diode, power diode use fire circuit. Using an equilibrium clamper clamping. 3 used as free wheel diode, free wheeling diode, as free wheel diode, to remove the negative part of the signal. The negative part in the power electronics devices, not in electronic. In electronic, because we don't have coils in electronics. In power electronics, most loads we have vector load. Okay, so free wheel diode. Yeah. Voltage Doppler also. Voltage Doppler. Voltage Doppler. Double the voltage 2 times. We input 10 volt, we output 20, or we output 30, or 50, or 100. Okay, double the voltage. Maybe 2 times, 3 times, 4 times, depending on so for diode used in this application, or also in the inverter circuit, but is a feedback diode. As a feedback diode and the inverter circuits, also in DC to DC converter. Part of the circuit should be a diode, maybe 2 diodes